All right, looks like we got a full house going on today. That's really exciting. So welcome. Hope you guys are all having a great time today at NDC. My name is Matt Burke, and welcome to You're Doing Exceptions Wrong. So I'm from the United States. I run a little small consultancy of just myself and a couple of clients. I'm really excited here to kind of talk to you guys about error handling and some of the things that I've picked up over the years. You can find me at all the social places. After sort of Twitter imploded, everybody went everywhere, and so I tried to come up with an account at most of the places. So if you're looking to have further conversations, those things are all available there as well. So I feel like exceptions have this pretty kind of bad reputation, right? We kind of look online, there's always these kind of new articles coming out about what's wrong with exceptions. There's plenty of really good rants out there about why exceptions are like the worst thing ever. And people are always talking about different trade-offs and different ways of trying to do error handling in their applications. And even at this conference, I think some of the other talks, you'll probably get some different approaches. Things like a result pattern are pretty common and popular. And there's a few other out there that are going on. But actually, my kind of hot take is that I think exceptions are actually pretty good. They're a great way of managing errors in programs, at least the types of programs that I tend to work on. And I think that, as .NET developers, you probably tend to be in the same boat. And I hope that at the end of this talk, we kind of all come away with some ways of dealing with exceptions better so that you'll agree with me that they are actually pretty good. But of course, the programming and community is pretty broad, right? There's different people are working in different types of applications, different kinds of protocols. And each of those have their own trade-offs and pros and cons. So I kind of want to lay out kind of where we're coming from just to kind of get on the same page, right? So if you're like me, you're probably tending to work on some applications that are primarily in C#. Maybe you're touching JavaScript or TypeScript or Java. These are kind of languages where garbage collection is kind of the way of doing memory management, and exceptions are the idiomatic way that errors are handling. And we tend to work on primarily kind of line of business kind of web applications. And by line of business, I mean they're fairly low risk, right? It's not a pacemaker. It's not keeping somebody's heart pumping. And then as a web application, if something crashes, it's not taking down the entire process, right? The server is still alive. It's still responding. It's still processing errors, processing data for other users. But one of the things that kind of comes out a lot of times when people are talking about the downsides of exceptions is exceptions suck because they're slow. And you'll see this one a lot, but in my perspective, I'm writing JavaScript half the time, and the performance level of an exception versus some other thing is just really not on my radar. And one of the studies I saw, someone had done a kind of an experiment, and they looked at measuring return codes, what if we just return true or false or some kind of enum instead of throwing an exception? And they're like, look, it's only a nanosecond. It's basically the same speed as a method call. Or when we do an exception, it's 22 nanoseconds. Why on earth would we do anything that is 22 times slower? But from my perspective and the kind of apps that I've tended to work on, that exception is maybe 0.01% of the time, and it's on the other side of a 50 million nanosecond SQL query. So I'm just not concerned about performance of exceptions versus return codes at that level, right? But all kinds of programming are cool, and if you're working on something where you do really care about that level of performance, I would love to hear about how you're doing your errors, because I love to learn about things from different communities and different styles of programming and see how that can enhance how we write things in the future. And the other one we'll sometimes hear is that exceptions suck because they're like a non-local go-to, right? And go-to is, of course, considered harmful. Nobody wants to write a go-to statement in their code anymore. And this sounds kind of fair, because anytime you're looking at a method, anywhere that you call another method, an exception could be bubbled up. It's going to jump out of your method and go off and do something else. And people say that's kind of bad because it makes it hard to reason about. But I think that that's actually pretty useful. It's not really jumping anywhere, right? It's going to jump up the call stack back the way that it came. And when I've worked in languages that don't have this feature, I get pretty annoyed with all the boilerplate that I've had to write to kind of okay, I got an error, I can't do anything with it, I got to pass it up to my parent, and I got to pass it up to my parent, and pass it up to my parent, sort of manually propagate that error up the call stack until you hit somebody who can, deal with it. But I think there's something interesting here in that we are seeing there is something here that exceptions have a little bit of a bad reputation. And I would like to kind of figure out why that is, and think about how there's got to be a reason that exceptions are the idiomatic error handling mechanism in great languages like C# and Java and JavaScript. The designers of those languages are not dumb. And when they set up to make a general purpose programming language, they chose exceptions as their default error handling mechanism. But I think the reason they get kind of a bad reputation is that we don't really use them very well, right? How many of us have had like formal training on exceptions, right? We probably had like a single afternoon in our courses that said, here's how you write a try statement, here's how you write a catch statement. Good luck, go out there into the world and kind of start using them as you think. And so since we don't get formal training and we don't develop like a philosophy around exception handling, we sort of just do what feels okay in the moment. We don't really have any principles or discipline about how we approach those errors. And then as a result, our error handling becomes kind of haphazard. Some apps do it this way, some apps do it another way, and it can become really hard to get a kind of cohesive view of how we propagate and deal with errors in our solutions. And so that's one of the things that I'm hoping to kind of address in this talk, is that if we kind of go through and look at some examples, we can build some principles that'll help us approach new scenarios and develop apps that work with exceptions better so that Hacker News won't have so much to complain about. So we're going to drill through this and we're going to get some tips and examples, and then we're going to kind of unpack a few core principles at the end that even if you can't remember all the little tips and details, if you keep those core principles in mind, it'll help you kind of make good decisions as you approach your error handling in the future. And so in kind of structuring this talk, I'm kind of indebted to this article called Vexing Exceptions by Eric Lippert. Eric was the kind of principal developer of the original C# compiler and then led the rewrite into the Roslyn compiler. He was, and also served on the language design committee for C#. So he knows C# really, really well. And he kind of, and this amazing article, which is old enough to drive, by the way, but I think that just makes it timeless and not dated. He breaks down exceptions into these 4 categories. And the idea being basically that if you can think about a different error and put it into one of these categories, it'll kind of give you some tips and ideas on how to handle the exception. And so that's what we're going to do. We're going to kind of pound through each of these. Some of them will take a little longer than others. We'll talk about what the exceptions are when they fit into this category and what that tells us about how we can deal with them, both in the throwing and the catching. So the first category that Eric talks about is what he calls the fatal exception. And these are the exceptions that you can't really predict they're going to happen, and you can't even really reliably clean up from them. And that's the key idea. Other languages might call this a panic, and some other languages like Rust, or a seg fault. Maybe if you're doing C, right, your app is done, it's shut down. And in C#, these are going to typically be things like the out of memory exception is kind of a classic example. You know, you can't really predict when you're just writing through some code that all of a sudden you're going to run out of memory. And then furthermore, you can't even really safely allocate more memory in your catch block. So if you wrote a catch block for catch out of memory exception, and then you tried to like log it, and that involves some string concatenation, that allocates more memory, but you don't have any left, what's going to happen? I'm not even sure. So the judgment of Eric is that like we can't really deal with these exceptions, and the best thing is to just let the app crash. The other example in C# is the Stack Overflow exception. Again, if you're writing something you don't really know when you're going to run out of stack space. If you're doing something recursive, you might know that it might happen, but you don't know exactly when. And again, when that happens, if you try to catch a stack over exception, what are you going to do? You're going to call a log method, which takes another stack frame. Like, you're just likely to make it worse. In fact, after .NET 2.0, you can't even catch a Stack Overflow exception. I don't know if that's still true in core, but the way the framework works, they realized that this was a problem, and even if you write a try-catch for Stack Overflow, it just blows through your catch block anyway. So our advice on these particular 2 types of exceptions is it's not worth writing a catch block specifically for them. If they occur, your program is dead in the water, and you might as well let it die quickly. So imagine if you were writing something to kind of recursively process a graph. Have anybody heard of the advent of code? It's like this. It's really fun yearly, like different programming puzzles at the end of the year leading up to Christmas, and a lot of them involve graph processing. You know, you're going to navigate a maze or one of those things. And recursion is often what you wind up doing for one of those. And so whenever you have recursion, you have this possible ability that you're going to call yourself a bunch of times and you're going to eventually run out of space. And so what Eric and I are suggesting is that you can't just run out of space and try to catch the Stack Overflow and fix it that way. Your best bet is to try to prevent it from happening in the first place. Keep track of the depth or the visited nodes or whatever, and just make sure it doesn't happen to begin with. So the fatal exceptions, the key thing to remember then is just that your process is basically going down. There's not much you can do. So it's better to not clutter your code attempting to deal with them, because having code that isn't going to actually work or is going to make things worse, it's better just to not have them. So fatal exceptions, honestly, they don't happen all that often, right? I can count on one hand the number of times I've had an out of memory or Stack Overflow in real production code. But the kinds that do happen quite a bit are the boneheaded exceptions. And so I love this name because the boneheaded exception is the one where you made a mistake and then this error kind of propagated out of that. The classic examples in C# are going to be your argument exception, your null pointer exception, maybe your index out of range exception. Sometimes invalid operation exception is kind of sometimes in that category, depending on how it's being thrown. But the key differentiator of these types of exceptions is that you have a bug already. You made a mistake. This exception is not a bug itself. It is telling you about a bug that you already have. And so the key thing that we think is important is that you don't try to catch these exceptions. Instead, you should prevent them from happening in the first place. They're telling you about a bug you already have. Just letting the bug happen and then reacting to it later is worse than just preventing it from happening in the first place. So imagine you were just doing an app where you kind of ask the user for an index and then you're going to write the index out of this, write the value from the list of the console. And it's like, oh no, I got an index out of range exception. Well, when you're first getting started, you might think, okay, I'll just throw a catch block for index out of range exception, and then I will console write line, hey, that's too big, right? But what I'm suggesting is that instead, that bug of being out of range is something that you had everything in your hand to know that was going to happen. So there's no reason to wait for the exception to occur. Instead, let's prevent it from happening in the first place. So you would ask the user for the index, go ahead and check that the value is within range, and do your kind of messaging that way, right? This is very straightforward. It's easy to read. You don't have the indirection of code jumping to different places because of an exception getting thrown. So production code should not raise boneheaded exceptions. You should have found and removed all of these before the code made it all the way to production. And so the key idea is that we're going to use these exceptions to know that we have an issue, and we're going to fix that bug at the source rather than being reactive to it. And so when I started thinking about that from Eric's article, and I started wondering about these exceptions and realizing that the boneheaded exception, like I said, is a symptom of the bug and not a bug itself. And I started to realize that these exceptions are actually a gift. And then we should kind of take that perspective. A lot of us, when we're getting started, we get exceptions and they frustrate us, and we think they're insulting us. But instead, we should think about them as another programmer has noticed that I made a mistake and has told me about my mistake so that I can repair it before it gets worse. I once worked a long time ago in PHP, and PHP had this philosophy, contrary to C#, that when an error occurs, it should write an error message into a log file somewhere and then just keep trying to go through. So you would wind up with log files that were full of basically syntax errors or any other problem, but the app would try to keep going, right? And I sort of adopted this philosophy for a long time. It's like, well, at least the app finished. The page loaded, something happened. That seems like a win. But I would start to get burned by this repeatedly, right? I had a null in some data, and I tried to interact with the null. PHP wrote a log file, but then kept going, and then that null wound up in the database and then showed up on a report or broke some metric or some graph 3 days later. And how much harder is that to debug rather than just getting a nice error message that says, hey, this was null and you tried to do something with it, app crash, go fix your bug, right? It is so much worse to troubleshoot when the results of our mistakes propagate through the system and get persisted and cause problems later down the road. So I thought that by writing try catches, when I came back to C#, I thought that by writing a try catch and ignoring the error, I was making the app more stable. But in reality, I was just letting the problems that were already there propagate deeper, and the bug burrowed further into the woodwork and caused more problems later. So I learned to kind of try to be grateful about these kinds of exceptions. You've been given the marvelous opportunity to fix your terrible code. So go back and do that rather than just kind of papering over it. And likewise, if someone else has given you the gift of telling you when you've made a mistake, maybe you should reciprocate and turn around and tell them when they've made mistakes. So do make sure that you throw boneheaded exceptions yourself when you detected that somebody else has messed up interacting with your code. And that person may be you, yourself, in the future, right? The users of your software are not just the end users who access the website or install it on their computer, but you build a shared module that's going to be interacted with by the other programmers on your team. And if you can predict that, hey, some of them might make the mistake, they might pass a null here, they might pass an empty list when we actually need a value, right? You're writing code that's going to be used by them, and if you have predictable problems that they might run into, it might be better to just warn them about it by throwing in an exception rather than trying to stumble through. And this isn't just for like writing libraries or open source software, though it's especially important there. But when you wrote code to be reused by other members of your team, part of this process of making that code work well for them is telling them when they've made the obvious mistakes that they might make. So we hit this once where a team member was writing a method to like apply some permissions to a user. Some admin screen, we were going to update their permissions or whatever. And so down in the service layer, he had a class that took a user and a list of permissions, and we're just going to figure out what all permissions the user already had, which ones they needed to add. We were going to go do that. And then either like the IDE warned him or he thought to himself, hey, there's this permissions list might be null. What should I do if it's a null? Well, I think I'll just convert that null to an empty list, and then the rest of my algorithm works just fine. But this exposed a real problem. We had a bug in the data binding layer, so that instead of getting the list of permissions posted all the way back to the service, we got a null. And that null then got converted to an empty list, and then basically all of the permissions got removed from the user. Right? It's like when you're working on a method, you got to think about what the intent of the caller is. And so when he was working on this method, he asked for a list of permissions, but he got a null. And so what was the intent if somebody passed the null in? Did they mean to pass a null in, or was that a mistake? It's like if you ask your friend for a glass of water and they don't bring you a glass of water, they don't even bring you an empty glass. They come over and they hand you nothing at all. You're going to be like, what are you doing? You're not going to be like, oh, thanks. And so like we should also in this case be like, hey, what are you doing? By throwing an exception. We need to understand the responsibility of our code. Working in this layer, it's not your responsibility to know what to do with a null. What did they intend when they passed a null? It may have been an error. It may have been meant to pass a null, in which case you've decided as a team that we're going to treat null as empty list, and then fine, document that and explain it to everybody. But you can't just guess at what people's intent was. Right, so we did find this in QA, obviously, but this was quite difficult to debug because as soon as you clicked save, you got booted out of the application because your permissions got deleted, and then you couldn't log back in. And the only way to fix this is to go into the database and monkey around with things. And that whole thing could have been prevented if we got that giant yellow screen of death or some error message that said, hey, something went wrong. You were supposed to pass a list of permissions, but you didn't pass anything at all. So rather than do damage to the system, we've aborted the whole operation, and you can fix it and try again. So use these exceptions to sort of help your teammates use your APIs correctly. Make sure that you give them the gift of explaining when they've messed up so that they can fix the problems in their code. But how do we do that well, right? Obviously, we're going to want to throw exceptions that have good error messages. One of the great things about exceptions instead of like return codes or some of those result-based patterns is how great a context you can give. Every exception has a nice string message where you can put all kinds of useful information in there. And you can also write your own exceptions with extra strongly typed properties if you want. But exceptions are really great at giving context, right? So you can really help explain what went wrong and nudge users into doing the right thing. So imagine that you're working on this cool new team, right? You've just joined this company, and it's basically the greatest idea ever. It's Uber for babysitters. You got this mobile app. You're going to summon strangers from the internet to come over and supervise your children while you go down and hit the pub or the grocery store. And you start there, and you download the code, and you boot up the app, and you immediately are presented with this error. right? Now, how useful is that? Okay, I know there's something wrong with the configuration, but I have no idea what it was looking for or where it was looking or any of that stuff. But if instead somebody had taken the time to write an error message like this, now your wheels are turning. All right, I need a database connection. I know where those are normally stored. I can ask a team. I can sort of figure this out. And it's not just going to be your own team. Like when I was working on setting up some microservices, we were doing DevOps, right? But that still meant we had a DevOps guy who did the DevOps stuff. And I would give him the code and say, these are the app settings that we need you to set up in Key Vault or app services or whatever. And I took the extra time to write these kinds of messages when the required settings were missing. So that when he installed the app and it booted up and it crashed, it would immediately tell him what went wrong, right? Okay, I typoed the name of that setting key, or Matt never told me about this one to begin with. But at least that turned like a multiple hour like debugging session into something very fast. If all he got was invalid config, then he's going to spend hours like going through my list and his check trying to make sure everything's right. But if we told him right off the bat, hey, I didn't find the database connection, then he can fix it right away, or at least come back to me and say, hey, your app requires this value, but you never told me what it was going to be. So I really also like this kind of message. Like another one that I've done is like, couldn't find a service to handle the customer created event. Did you forget to register it in the dependency injection container? How many of us have gotten errors in .NET because we never registered a class in our DI container, and instead we just get this very cryptic, confusing null or something, and you don't really know what went wrong? How much better would it be if those error messages like, hey, couldn't find this class, this is the class I was looking for, did you forget to register it? Yeah, that's the very obvious mistake that somebody's going to make. And if you can know ahead of time that someone's going to make an obvious mistake, a really good error message that nudges them in the right direction will save them an awful lot of time. So I really like that did you forget kind of language. If you know you detected an issue that has an obvious fix, well, tell them what the obvious fix is so they can get on with their day. Another one that you will see a lot is like unexpected case, whatever, inside of a switch statement. C# doesn't really have exhaustive switch statement checks. So if you have some enum and you're doing something with all the different values of the enum and somebody adds a new one, well, if you have a default case, then that's going to get caught there, right? It can be really good to go ahead and throw an exception in that case to say, hey, we wrote handling for case A, B, and C, but somebody added D, right? I don't know what to do with D, so I'm going to throw an exception, and I'm going to tell you not just unexpected switch case, I'm going to tell you value D was not handled. And that gives everybody who encounters that error a little bit of time and ease of fixing it, right? Other languages, this would be a compiler error. C# can't do that, so we turn it into a runtime error, which is the next best thing. And I would say there is such a thing as too much context. Obviously, you don't want to leak any secrets in your exception messages. So, like don't be writing a login function where you check the credentials and throw an exception, but, stick the username and password in that exception. That seems really helpful, right? But this isn't just bad, that's screaming bad. Never write anything in an exception message that you don't want to show up in a log file one day. Because I guarantee you it's going to show up in a log file one day, and now you have a reportable breach. And imagine the fun you're going to have talking to your chief legal officer and your marketing officer about how you have to do notifications to your users and do password resets because you shipped the user credentials to an unsecured third-party log aggregating service. So just kind of think about what you're doing and don't go overboard in giving too much context. If you work in healthcare, like PHI can be a protected health information. That's probably an American term, but that kind of data should also not be in there. You don't want to say, user ID, whatever, failed because they had this condition. Now you've logged something else that you're not supposed to log. And so also be careful of the jargon. As programmers, we kind of know the internal code names and metaphors that we use inside of our own classes. We don't want to write error messages that cause the other programmers to go to Stack Overflow to figure out what's going on. Now, Git is famous for very poor error messages. If I got this error message about a branch yet to be born, I have no idea what that means, right? And even reading this Stack Overflow from 12 years ago, by the way, I still don't know what it means, right? So whoever wrote that error message, they probably could have phrased that in a way that would be like, oh, okay, now I know what weird situation I've gotten myself into. But nowhere else in Git have I ever talked about branches being birthed. So I would never have any idea what this meant. The other thing to keep in mind is that end users might eventually see it. We think it's pretty bad practice to just bubble up exceptions and just like present the error message right to the user. But lest he who's never sinned here throw the first stone. And I think that like programmer insider baseball is not especially friendly. Things that are clear to us as programmers can be pretty scary to our non-technical users if they see this, especially with all this AI talk about the computers becoming self-alive and taking over. And we want to get rid of this before someone takes their hammer to their computer about preventing the machine from rising up and slaughtering their children. That's all fun and games, but this did actually come up. I mean, one time I was working doing some stuff with a bank, and banks are a famously amazing architecture. There was this fantastic COBOL layer down at the beginning, at the bottom, but nobody wanted to write COBOL, so they slapped a Java layer on top. And then we were coming in to kind of help work on this VB6 app, but we didn't want to work on VB6. And in fact, nobody could compile the VB6 except for one machine that was kept air-gapped in the IT closet so that it never got any updates and stopped being able to compile the code. And so we were going to work in .NET 2.0. We were going to do some COM interop between these two things, right? And then we're going to do SOAP. Let's throw SOAP in there for the heck of it. This is the most enterprise-y stack you've probably ever seen in your life. But even enterprise Java developers wanted to have a little bit of fun, as we learned when we started getting this error message back while we were doing some validations. And I don't know if you can see it. Have you ever heard of an ID10T error? It looks like idiot, which is not a very nice word to call users. This programmer clearly thought he was being kind of funny. This is like the worst programmer joke of all time. This was at a bank, by the way. I had to wear a tie, this shouldn't be happening. And that's all fun and games until we bubbled that up and put it in the screen and called some senior vice president an idiot because he forgot to put the city name in the form, right? So, hopefully we caught this stuff, but it just goes to show what can happen. And while we're on the topic of not being confusing with our error messages, I think another thing I've seen is make sure you don't reuse the built-in exception types for purposes other than what they were intended for. Everybody knows what null reference exception means. We know what argument exception means. If you were building an app about debate, why would you throw an argument exception because of I don't know, that's a dumb example. So you know what I mean? They have good meanings and people know what they are, and so we shouldn't try to change them. This burned me pretty bad once, where we were working on some enterprise-y factory class that had a method that took a parameter, and somebody was like, well, we better check the parameter for null, which is great, but then they threw a null reference exception, right? And maybe you can see where this is going. When you're dealing with the compiled code in production, you don't get line numbers anymore. All I know is that null reference happens somewhere in this method. Imagine if this method were another couple hundred lines. Now I'm trying to figure out how this null got in here and where it got used. And in fact, I see the if check, if I'm not very careful, I see the null check at the beginning, and then I think, okay, from here on out, factory is safe to use, right? Because I'm not expecting that that's going to throw a null reference exception. So this was very confusing. Spent a lot of time looking at the wrong thing, chasing red herrings and wasting time. Whereas if we had used the correct exception, we would know immediately what the problem was. And in fact, you can go one further and pass the name of the parameter straight on through. And so you might be asking yourself, okay, well, should I ever create, the built-in ones are great, but should I ever create a custom boneheaded exception for my boneheaded users? I'm going to say no. Don't create custom boneheaded exceptions. There's two reasons why you might want to create an exception, and neither one of them apply to this style, right? One, you might want to add some contextual properties. You want to add an custom property on the exception that has some extra data. Or you might want to be enabling specific catch blocks, right? You're writing a custom exception so that somebody can write, try this, catch my new custom exception. But remember, neither of these really apply to the boneheaded exceptions. We don't want people to catch boneheaded exceptions. They are bugs in their code that they should fix. If they're really going to do it, force them to do string comparisons on the message. That'll get caught in code review unless you've outsourced that to AI, where anything goes. So again, we don't want them to catch those. So all of this looks a little bit similar, and I want to take a brief digression about debug.assert, if you're familiar with that. If you haven't seen it before, it looks like this. You can write this in your code. You do debug.assert condition. So for example, you could assert that some variable is not null. The end effect is that an error is raised automatically if the condition is not met. And these are so useful that like other languages have like built-in support at the syntax layer for them. Like Java, you can just assert condition or assert foo doesn't equal null or whatever. They have the same end result. And so when you look at that, you think this looks an awful lot like a convenient way of doing if whatever throw exception, if whatever throw exception. I could just do debug.assert. But I want to point out that they differ in some very important ways. And primarily, I think they have very different purposes, different audiences. Those boneheaded exceptions you are raising because you think somebody else made a mistake interacting with your code. Whereas with the assertion, it's sort of you yourself are the intended audience of this code, of these assertions. You're putting them in to kind of document what you think should be true about the program at this point in time. So they're sort of meant for you and yourself. The really classic example that I think of is whenever I find myself writing a comment that says this should never happen, or I should never get here, or this value should never be empty, this list should never be empty, right? Those are great opportunities to use an assertion because not only does it document what you're thinking, this shouldn't be null, or this shouldn't be empty, but it is also like executable documentation that actually checks what you're saying is true, is actually true. So these are very great for documenting the invariance of the system. If you're working on, like you remember, and maybe some of us went to computer science classes. I only had a few, but like one of the most boring sections was talking about preconditions and postconditions, right? When you enter the method, this is what we expect to be true. When we leave the method, this is what we expect to be true. That can be a really great use case for debug.assert. You're saying these facts about the world should be true, and we can enforce that. The other thing you need to keep in mind is that debug.assert and friends are usually compiled out in release mode. So when you do a release build, none of those if checks run, none of those assertions ever get raised. So they're not going to be a replacement for boneheaded exceptions, especially if you're writing a shared library, because the consumer of your shared library may be consuming your release build. And if your release build just had a bunch of, if you just use debug.assert everywhere, now none of that stuff actually runs in production codes for them. So they're not a recommendation. I found them actually, since a lot of us are C# developers here, really useful if you're working with the, that new nullable reference types feature, and the compiler is like, hey, this could be null, and you're like, I know for a fact that it can't be null. By the time we got here, it can't be null. Wait, that's the light bulb moment. Maybe I should do a debug.assert there. That does two things. It both writes down the fact that it documents the fact that I'm pretty sure it can't be null here, and it actually makes the compiler happy. The compiler sees that and says, oh, okay, I trust you now. From the rest of this method, I'll let you get away with it. And in debug builds, if it turns out to not be true, it's going to throw a big assertion that says whatever wasn't null failed there. So I really recommend debug.assert. Just kind of know what its purpose is. It's more like a private implementation detail rather than publicly telling a caller that they messed up. So these are what we talked about, the boneheaded exceptions, right? If we learn to think of these as a gift, we'll have a much better time. We'll both not worry about them, catching them, and we're going to be more generous about how we throw them and give them to our users. The third category that Eric talked about in the article is what he called the vexing exception. These are the exceptions that aren't really exceptional, but you're kind of forced to deal with them, right? And these are kind of examples of bad API design. The classic example is the format exception. I know we've all gotten those. And the trouble is you can't really even guard against it ahead of time, right? So if you're writing some method that tries to parse some user inputted text into a number, right? The problem is that int.parse is going to throw that format exception if the text in the text box isn't very numberish, right? But how would I guard against that ahead of time, right? Like I would basically have to implement parse for myself, right? So this is very vexing. It's very annoying that the API of int.parse works that way, right? It was so irritating that they, in later versions of .NET, it kind of came around to this try parse pattern. So you'll start to see this in a lot of places for this exact purpose. The only way for you to know that that text wasn't numberish was basically to implement a number parsing algorithm yourself. And so they do this pattern as a way of returning two values true or false on whether or not it was successfully parsed, and then giving you the actual value so that you can work with it that way. So if you're working and building an application and building an API, don't design APIs yourself that throw vexing exceptions. Give your users an out, give them a way, use the try parse pattern or some other pattern where you can help them out, right? So that they don't have to wrap every call to your method with a try catch. When you do have to work with APIs that have vexing exceptions, I think the best thing to do is going to be to try and catch that exception as close to the cause as possible. Remember, these are like exceptions that are not exceptional. They're going to happen all the time. And so we ought to design our code around that fact and not let that exception bubble up all the way up the stack and abort an operation. We're kind of expecting this to happen. And it would be nice if we didn't have to use a try catch to do it, but sometimes that's what you have to do. I was working with Cosmos DB once, and we were trying to do this like archive thing. So I wanted to like check if an object existed, and I expected read item async to give me a null if it didn't exist. So if it existed, I was going to archive it, which involved just moving it to some other place or whatever. And then I wanted to replace it with the new value. I expected read item async to return null if it didn't exist. But what in practice happened is it threw an exception that the document doesn't exist, right? This was very vexing. I didn't want to write a try catch because they're a little harder to read. I wanted to have this nice straightforward if null, if not null kind of Boolean logic. Instead, we had to replace it with a more specific check. And since this was very common, I didn't want this Cosmos exception bubbling out. I wanted to handle it right here. I intended that half the time the object wouldn't exist. So it was very expected that the object wouldn't be there. But the key thing that I want to point out about this is that we're also like catching very specific exceptions. I'm expecting an object not to exist, and when that object doesn't exist, I know I'm going to get a Cosmos exception, and furthermore, I know I'm going to get a Cosmos exception where the status code is 404. Those are the only scenarios in which I want to ignore the error, right? If I got an authorization exception, I don't want to ignore that. That's a real problem. Right? If I get some kind of socket timeout or some other kind of non-Cosmos exception, I don't want to ignore that. That's a real problem. I don't have enough information to handle that kind of error here in this method. I want to let that bubble up. So if you're working with those exceptions, try to avoid making it possible for them to even happen. Okay. So vexing exceptions, don't design APIs that raise vexing exceptions. And if you have to deal with a vexing exception, try to deal with it right at the cause and get over with it. Get it over with. The last category that the article talks about is what we call exogenous exceptions. And Eric has a very extensive vocabulary, so I had to look that up. But it means derived or originating externally, which is also sort of hard to parse as well. But the idea is that these happen when the cruel outside world encroaches on your nice pure programming, pure logic, right? They come from outside of the program. They're not necessarily your own bugs or faulty logic. There's really nothing you could detect ahead of time that this is going to happen. These are going to be things like the disk ran out of space, right? A mouse chewed on the network cable, right? All of Azure's US East 2 data center is on fire, right? There's no way for you to know that these are happening ahead of time. And so you kind of have to, you're going to have to deal with them eventually. And so one of the first things is like, you also just can't assume that you can if check your way around them, right? So imagine if you're writing a method that you know a file may or may not exist, and I want to get the contents of that file or null if the file doesn't exist. So I write a method like this. This works fine, it seems right, it works for, you know, for some scripts and stuff. But there's actually like a subtle bug here, right? And if you're into like classifying bugs, one of the things you might put this under the category is the time of check is not time of use, right? There is a possibility that the file would get deleted between the time that you checked it existed and the time that you tried to read it. It could get deleted, someone could change the permissions, the network drive could get unplugged if it was a USB or whatever, right? So there is that possibility. So if you really want to be as most safe, then you're going to have to just catch the exception anyway. Remember, this method already expects the file not to exist. That's a normal scenario for this context. So the best thing to do is try to just catch that file not found exception and treat that as the null. So rather than doing a file exists, which we can't trust 100% of the time, we'll just go ahead and try the operation and deal with the exception. The next big thing, and this honestly, like if we remember one thing from this whole talk is like this one. This is my biggest pet peeve when working on large enterprise applications. Do not swallow or hide the fact that the exception occurred, right? This makes things so much harder to work with. We are not making our programs safer when we ignore the error. Sometimes we feel like that. Well, at least it didn't crash. At least it didn't spew some error message to the user. At least we didn't see that yellow screen of death. But is the app actually safe? There was already a problem. We just ignored it. We're not making it more correct by papering over errors and pretending they didn't happen. Plus, they're absolutely infuriating to debug. So this is like a text I got from a coworker after spending hours rolling through an application where there was a podcast feed and the podcast feed was empty, right? The problem turned out to be a certificate error with the network. That happens all the time. There was no way that because we didn't like present the error to the user, we just said, oh, there was an error, here's an empty list, right? Now we're trying to figure out what went wrong with the little database that's inside the app and why the list is empty. Did the user delete all the things? Like trying to troubleshoot this without good logging, without good metrics is so much harder than it needed to be. How much easier would this have been to troubleshoot if instead of just showing an empty list, we didn't pretend that the error didn't happen and we just said, hey, there was a network problem downloading the podcast feed, right? So much easier to figure out what the problem is rather than digging through all that stuff manually. So imagine you're writing a method where you're trying to find the balance of a customer's account, right? You're just going to query up the user from the database. If the user isn't found, you're going to return a 0. That's not great, but it's not really what I'm talking about here. We have to return something because the signature of the method is return a decimal. So if the customer's not found, or return 0. That's not great, but we're working on this. If the customer is found, we're going to return the balance, right? And this seems good, but we're writing it and we're like, we got an exception once. I don't really want that. I want to pretend that it didn't happen. I'll just wrap this in a try catch and return 0 in that scenario too, right? We've met the signature of the method. We return some kind of decimal no matter what. And when we're new, we kind of think, okay, we made our software more stable, right? It's no longer throwing exceptions. But we've made this method very confused, right? If I call this method and I get a 0, it means one of 3 different things. It's possible that the customer didn't exist. It's also possible that the customer did exist but had a 0 balance, or it's possible that some random network blip happened and as a result we turned 0. And what happens if I trusted this 0? What if I was doing something to like close accounts on customers with 0 balances, right? Now I've accidentally closed some customer's account just because there was a little momentary network drip, right? And this isn't the only place that this kind of thing shows up. Sometimes you might see catch exception and return an empty list, or catch it and return null, or catch it and just ignore it outright. These all have the same effect. Even in like your void methods, if you ignore an error and I call this save method intending to save some widget and I didn't get an exception, do I know for a fact that that widget actually got saved? I have no way of knowing, right? And I might do other things based on the assumption that it succeeded. I thought I saved the widget, so now I assigned a user account to work on the widget, and now some dashboard somewhere else is broken because the foreign key constraints are violated or whatever, right? So the error that originally happened, some network blip, has now caused bad data to be stored in our database, which is causing other things to break further down the app, and that is so much harder to troubleshoot than just dealing with the fact that this error occurred in the first place. So I do think we have to process errors at some point. Like you're going to have to show a message to the user. You're going to have to do something like that. But I think we have to make sure that we catch these errors at the right level, right? So imagine this is your software stack, right? It's kind of creaky and it leans left and right. It wobbles and it's full of holes, but it's yours and you kind of have some affection for it. The right place to handle most of your exceptions is going to be way up near the top, right? That's where you have the most context. You don't want to handle them way down deep in the stack because you have very limited context, especially in methods that are reused in a variety of situations. You don't know the best way to handle a particular error. The data layer is going to be the wrong place to handle most types of exceptions. I really don't like seeing try catches in like your data layer because sometimes you can ignore the error because it doesn't matter. It was a best effort. Sometimes it's really important that that actually happened, right? And if the data layer is papering over the fact that an error happened, you aren't able to make better decisions further up. Most of your exogenous exceptions are going to originate way down in your data layer, because that's where you're doing I/O. You're making network calls to the database, you're reading and writing files, you're making API calls. So they're going to originate there, but you really don't have enough context to process them there at that layer. And in fact, I would say most applications, if we're working with like a framework like a ASP.NET Core or like a desktop framework, most apps don't really need a whole lot of catch blocks at all. Like, let the framework catch the exception. One of the favorite things to do I like doing with ASP.NET Core is letting those exceptions bubble all the way up and having a global handler where you can kind of plug in and say, okay, these kinds of exceptions I want to return 404. These kinds of exceptions kind of mean just a 500, the default. And so you can kind of configure that all in one place, all the way at the top layer that's kind of handled by the framework. And that makes it a whole lot easier to read and a whole lot easier to kind of reason about, because there really isn't anything we could do to recover. We tried to save something to the database was down. What are we going to do? We can't really recover from that, so we might as well let that request crash and let the front end display something practical to the user. Now, sometimes you might have some specific scenarios, which we'll get into, right? So if you're going to have to write a catch block somewhere because you want to try to do like a retry or something like that, don't do what they call the Pokemon exception handling. Unlike Ash Ketchum, you don't got to catch them all. So here's an example of one that we actually ran into. So we're doing something that calls this HTTP API. And this is kind of an annoying partner API that you kind of had to wake it up. The first time you called it, you would get a 503 service unavailable. But if you called it again a couple of times, it would eventually kind of come alive. Now, the purist in me wants to force the vendor to go and fix their buggy API, but I got to ship, and that ain't happening. So sometimes you got to be pragmatic and write yourself a little retry loop. All right, so we did something like this where we kept track of the number of attempts. We did catch exception. There's that Pokemon exception catching. We slept for 100 milliseconds to give it some time to warm up. And if eventually we would run out of retries and propagate up the error, right? But the problem is, what happens if this API threw something that wasn't that expected 503, right? It's still going to get caught in this exception block and get retried. And like, what if it was an authorization problem? Well, retrying it 10 times isn't going to fix the authorization problem. Or worse, what if it was some kind of timeout, a 30-second timeout, tried 10 times, takes 5 minutes, right? So we should have just given up. If they're down enough that we're hitting timeouts, us retrying is not likely to fix it. We better let this propagate up and deal with it in some other way. So the best thing then that we could do then is try to be very specific about the scenario that we really do want to retry. We only want to retry when it was an HTTP exception, and specifically an HTTP exception that was the 503. And this forces us to kind of work in precisely in what we're doing. Now, if we're in C#, I wouldn't tend to write this kind of code myself anymore. There's a really great library out there called Poly. I'm sure some of you are familiar with it. You can configure all of this stuff. You can do retries with like exponential backoff, try again in 1 second, try again in 2 seconds, try again in 4 seconds, all kinds of really cool things. But it gives you the same level of power, and you make sure you configure it not to do any old exception, but specifically filter for the scenarios that you know to be retryable. So a lot of apps are going to have a Pokemon catch at some level, maybe the top level, but handled by the framework. But I think we should kind of avoid those in general and be very specific about what we're trying to catch. If you do feel like you want to catch and rethrow, though, sometimes that can be useful. You can catch any old type of exception because you want to rethrow it, but adding a little bit more context along the way. So you want to kind of evaluate if this makes sense for your scenario. So one time we had something that was doing removing permissions, and we would try to catch an exception, and we were going to add a little bit of extra detail. We were going to say what permission and what user ID got removed. And that does help somebody debug this in the future, right? But the important thing is that we also pass along that exception as the second parameter to the constructor. So most of our exceptions in C# have the inner exception property that's inherited from the base exception class. So you want to make sure you make use of this. Your logger will know how to deal with that. It will log your own message that you couldn't remove read permission from user 47, and it'll also say the inner cause of this was a network timeout or a database error, foreign key constraint, or whatever. And now you've got both the details of what user was impacted, and you've got the real underlying problem so that you can go and fix it. Your logger will deal with that. They know how to handle those. And so you might be thinking, can I make it a custom exception for this scenario? I'm going to catch something and I want to wrap it up in my own specific exception. I would say maybe. Think about it a little bit. Maybe if you have a lot of like extra structured data that you want to add, the details of this aren't important, but like this is the SQL exception from .NET. They've got a lot of custom properties added to it. They've got the, what line number of the SQL script went wrong, what stored procedure was involved, all of the stuff that kind of comes off of the underlying SQL Server protocol. They kind of make that available to you. But that's a lot of work to add all these properties. Like making a custom exception class it's not hard, but it is a little tedious. They're supposed to be serializable. They're supposed to inherit in the right structure. They're supposed to have the right constructors. So it's just a lot of work if they're not going to have a lot of value. I've not reached for that very frequently in my career. When you want to use them is if you're building something like that HTTP exception where you're going to also propagate the HTTP status code to help somebody filter for specific scenarios. But most of the time, honestly, just throw the extra context right in the message, like we did when we interpolated the permission name and user ID. And this is a C# pretty heavy .NET conference. I want to be remiss to skip this, but make sure you don't lose the stack trace when you're doing a catch and rethrow. It's kind of an annoying quirk in C# that if you're doing something risky and you catch an exception and you test if you can ignore it, but then you want to rethrow it, you've made a huge error here. That little 3 extra characters of including the EX will reset the stack trace. So now when you get this in a log, it looks like it came from right here in your catch block rather than originating somewhere deep inside of do something risky. And that's going to be very, very tricky to figure out. You've lost exactly where this happened. And so if you do something risky called 2 database methods, now you don't know which one went wrong. It's going to be a lot harder to figure out. So that resets the stack trace, just including that little EX there. So instead, you just drop it. And then this will cause C# to rethrow the exception, but it will retain the original stack trace that was deep inside of do something risky, and you won't get confused. The other thing you can do is use some of the newer features of exception filters that came out in C# a few versions ago, where you can write a catch block with a where. I only want to catch the exception where some fact about that exception is true. This will have the same end result. Furthermore, when you're dealing with exceptions, remember we talked early about exceptions being a non-local go-to and that being one of the downsides of them. And it's true, you do kind of have to be aware that if you're working in a method at any time, some exception could occur and jump out of your execution, right? So if you have things that you need to be careful about disposing of or cleaning up after yourself, then you need to make sure that you handle that appropriately. Excuse me. I had an app once where we were, trying to log visits to some SQL table, which is, terrible for load, but hey, it was 10 years ago. And, so we would open a connection, we would try to insert in the database, and then we would close the connection when we were done. This seemed great. But we started having issues with performance was really tanked. And the problem was that we were getting some errors in some of these insert statements. We were having some locking constraints, which would cause this method to throw, which would cause that close method to never get called, right? And this leaked SQL connections, which made everything much slower because these connections, once they're leaked, you got to wait for them to be returned to the pool and be reused by another request. This was really bad under load. And so the fix, of course, is to refactor and use the using statement, right? Now, this pattern exists in other languages. It's generally called the try with resources pattern. Java has it, Python's got it, JavaScript will be getting it at some point. C#, it's the iDisposable pattern. So things that are disposable, make sure you wrap them in that using statement so that they automatically get disposed of. Even if there is an exception that bubbles up, the close method on that connection is still going to get called. And when we do that, it fixed all of our performance problems. Even if we were having constraint problems, the connection would get released appropriately. If you can't use the using technique because the library using doesn't support iDisposable or you're trying to mix and match between things, then the pattern is to do your risky thing and wrap around a finally block. You can have a finally block without any corresponding catches. That's totally fine. So if do your risky thing throws any exception at all, you're going to be confident that your cleanup method is going to get called on the way out. So that's what we learned about exogenous exceptions, right? You can't really detect them ahead of time. Please, please, please don't hide them or pretend they didn't happen. think about what the right level to catch them at is. It's going to be higher up at the top and not deep down in your data layer. And think about adding a little bit of context when it's appropriate. All of these are going to be ways to make these errors easier to work with these errors in the future. So let's recap and look at the categories real quick, and then try to pull out some principles that I think are going to help us work with our errors, right? If there are fatal exceptions, we're going to say don't catch them. That was the advice. Boneheaded exceptions, null reference, argument out of range, etc. Also don't catch. The vexing exception, catch them where you have to, right close to the cause so that you can kind of deal with it right away. And then the exogenous exceptions, the main advice is they're going to happen, but you need to know about them, so make sure you don't hide them. And if we stand back and look at what we've covered and the practical examples, I think we can unpack a few principles. So even if you don't remember all the details of those, you keep these principles in mind, it'll help us make good decisions in the future. Exceptions are the key part of the observability of our systems, right? Observability is kind of a word that's kind of up and coming. There's other talks at this very conference about observability. And it's the idea of having insight into the running status of our applications. If our applications are encountering errors, we need to make sure we know about them. And exceptions are a key part of how in .NET we know about the errors in our applications. So we want to make sure that we're not hiding them. Those problems are still happening, and if we just have empty catch blocks, we're not making the problem really go away. In fact, a lot of times we're actually making the problem worse. So we need to not be afraid of exceptions, and we need to let them tell us the information that they're telling us. And when we ourselves detect a problem, let's not be afraid to throw exceptions that we detect a scenario that's an error. Let's make debugging easier for our other programmers on our team by going ahead and throwing those exceptions. And when you throw them, make sure they're nice and have good context so that you can be kind to the other developers on your team. So, and if you wanted to get down to like one key thing, this would be the distillation of everything. I would say we, as a programming community dealing with exceptions, I think we want to write a whole lot less catch statements and write a whole lot more throw statements. And if we think about what that exactly means and kind of unpack all of the kind of principles we've looked at, we'll get a good handle on errors, and maybe Hacker News won't have so many complaints in the future. All right, so that has been, you're doing exceptions wrong. If you follow all my advice, then you will do exceptions right. And I hope that becomes useful to you in the future. Thank you very much.